We have this 7-Eleven that gets burglarized like literally once a week. Guy walks up with a crowbar and he swings at the door, and that's the end of our video because our guards get on and say, "Hey, jerk, get out of here. The police are on their way." And the guy walks away. Whereas if you had a dumb camera, you get this really cool video that for the next 45 seconds, you see this guy banging on a window. And so what we've had to do is we've had to train the market that like, hey, prevention is possible.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewell. Dave Selinger is the co-founder and CEO of Deep Sentinel, an intelligent crime prediction and prevention system that stops crime before it happens using deep learning vision techniques. Prior to founding Deep Sentinel, Dave co-founded RichRelevance, an AI recommendation company. Super excited to talk to him. Maybe you could actually start by just describing what your company does and how it uses deep learning.
Sure. So Deep Sentinel is a physical security company. So we have cameras and we actually protect facilities. It's not cybersecurity protecting computers. We are kind of a competitor to ADT, which I'm sure you've seen the lawn signs for. And the whole premise behind that business was, hey, ADT doesn't work. A lot of people don't know this, but like police departments across the country basically don't respond to burglar alarms because they're 99% false alarms. And so they just really don't help people protect their families. Maybe it makes you feel better for a little while, but it doesn't actually solve the problem. And so I started looking at like what really wealthy people do. And they have people that sit in a guard shack and they watch cameras all day and they pay tens of thousands of dollars a month for that service because it works. And the problem is obviously if you got a bill for $25,000 a month, I would say there's a very small population that's going to like write a check for that every single month, right? And so what we realized was that if we use AI to both make the guards more effective, more efficient, and able to do their job, and then we use all the technologies that are available now to kind of drive that into unit economics, where instead of having one guard or 10 guards protecting one house, we have one guard protecting 10 homes, then protecting 100 homes, and now protecting 500 homes. And that's really what our business is all about.
Gotcha. So the vision systems are sort of deciding which cameras are interesting to look at, and then a human actually kind of verifies that there's something going on. Is that right?
Yeah, I mean, at its rawest, that's exactly right. We use vision systems, which is where deep neural networks have made a lot of progress to choose what to look at. And then we're getting increasingly sophisticated with that to not only choose which cameras to look at, but where to look in the cameras, what are the areas of interest. Hey, if something happened 5 seconds ago, here are the references that kind of wrap around this event so that you as a human being have the full context, even in the course of like half a second.
So how much of that is sort of interface for the operator and how much of it is like intelligence? Like where do you sort of invest your effort?
That's a great question, right? So because nothing exists like this, we had to build the company in a vertically integrated fashion. So we actually build our own hardware. Behind me, we have our hub, which we actually built ourselves, and that runs the AI in the customer's home. And so we've had to invest a lot of effort. A vertically integrated business is like by far the most complex way to do it. So we have a lot of investments that's gone into AI. We've got a lot of investment that's gone into operations. But really the thesis of the business is, hey, AI can change all of those things. If you use AI correctly, and this is an AI-driven business, because of the nature of what we do, which is video-oriented, we can make our operations team smarter. We can make our customer care team smarter. We can make our engineering team smarter by integrating that throughout.
Interesting. So what's the part that runs in the customer's home? You actually do some processing before it even goes to you?
Yeah, I'll tilt this to the side here. So right there is our hub. It's right here in my office. Down here are the next generation versions of the hub, which we're working on right now. This is both my home office and our R&D lab, seeing as COVID has helped us really concentrate our real estate effort. But yeah, so what we run in the home actually is almost everything. So we've really focused on moving everything to the edge. And there's a lot of kind of work that's being done right now on edge processing. From what we're seeing and what we're building on, that curve is just astronomically improving year over year. What we currently do is we run a version of Linux in the home that has basically all of our BI stack. It's all encrypted and whatnot, but we run almost all of the business logic in the home so that the decisions can be made in real time with the camera. And as you might guess, in a security context, the difference between real time and 500 millisecond latency in communication is everything. And so we're able to do stuff at just very, very rapid speeds by doing that.
And so what exactly is the business decision? Is there like a possible issue? Is that right?
Yeah, so if you think about if you've got a Ring at your house or a Nest camera and you actually turn on alerts, which I highly recommend you don't do, you're going to get like 1,000 different alerts. And so the first decision that the AI has to make is this alert worth reviewing in further detail, and to what detail? Then the second thing it needs to determine is what's in the field of view, and is that worthy of taking the time of a human guard to review this? And then the third decision is, when the guard is reviewing this, what are all the other pieces of information I need to share with that guard to make sure they can make an informed decision in the course of a couple of seconds? And so again, all of that runs in the home on that hub. And then by doing it in that local situation, all that kind of back and forth communication happens, in sub 10 millisecond type timeframes versus, 20 to 500 milliseconds back and forth to the cloud.
Well, that's really interesting. Can you talk about your hardware? Like what?
Yeah, sure. So the current version of hardware that we're running is a Qualcomm Snapdragon 820. So it's what you'd find in a Samsung Galaxy S6. And so we literally, actually, if you open up our hub and you like peel back all the boards, you're going to see something that is exactly shaped like this at the bottom of the hub. And there's a bunch of circuitry around it. But it's literally kind of the reference design for the Samsung Galaxy S6 sitting in the middle. And then we put all of our electronics around the outside of that. And that was quite an adventure for me because, going into this, my experience with hardware had been the robotics that I built in a lab at Stanford when I was there. And that was, build it once, use it once, and, make it do everything that it can. And then, a bunch of Raspberry Pis and the types of stuff that you build in your house, right? Like that's a robot that I built of a BB-8, using a bunch of Raspberry Pis and Arduinos and stuff like that. And so you think you know about hardware. Just very, very briefly, I will summarize all of my learnings of the last 4 years. You don't know diddly squat. If that's what you don't know anything about hardware. And so we really had to take the time to learn about how do we design that and manufacture that with high quality and solve a bunch of the problems. That last mile of real human beings is really important.
Yeah, I feel like all of my friends that do hardware, I'm a little jealous because it seems so cool, and they absolutely hate it and, and always complain about it. So
I don't hate it. I would say though that the amount of learning that I experienced versus the amount that I expected is a ratio of about 10 to 1. Whereas, for most smart people, like you go into something, you kind of get a sense of it and you're like, maybe I'm off by 40% or 50%, or maybe, it's double. Hardware was definitely a 10 to 1 ratio of how much I had to learn in order to get, into market and be productive.
Interesting. I
But
wanted to ask
it's
you
cool
actually.
stuff though. I mean, it's amazing what's happening in hardware right now though. I will say it. Sorry to interrupt you.
Oh yeah, like what's going on?
I mean, the Google Coral board is really phenomenal. The work that NVIDIA has been doing is really great. I think my favorite thing though is just that it's not all about NVIDIA. So like on the training side, it's still really like an NVIDIA dominated world. And you can get into China, where in China I see a lot of new R&D happening outside of the NVIDIA world, but a lot of that's not, really readily available to us here. On the mobile and edge side of the world, you've got everything from like Rockchip has what they're calling an NPU, that is a neural processing unit, and it's an accelerator. You've got the Google Coral board, which is driving quantization, which I think is super sweet. That makes things, much simpler from a mathematical perspective, but way, 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 way faster and way lower power. You've got NVIDIA doing their Jetson series. But I think overall, what I would say is that, in the training side of the world, NVIDIA's here and everybody else is here. On the runtime side of the world, NVIDIA's here, and there are people that I think that are better, significantly better on a cost for performance and an overall performance basis. And so we're seeing a lot of innovation happening there. NXP, which is another chip manufacturer, they're launching their own NPU in Q1 of 2021. And there's just a lot of promise to see a lot of competition, which I think is going to drive a lot of improvement.
Mm-hmm. And actually, how do you evaluate, like, why did you decide to go with the Qualcomm board versus something else? Like, how do you think about that?
So we chose the Qualcomm board, great question, in 2018. And there were 3 primary factors. The first one was, does it do what we need it to do, right? Which, by the way, like at the time, there were a lot of things that would say, like, we do AI, and they would come with like a pre-trained inception model. And if you changed anything on it, it would break. The early days of kind of runtime AI were pretty limited in terms of the scope of what things could do. So that was number one. Number two was it's a consumer price point. So we're selling direct to consumer. And so while my hub that's a $250 COGS piece of equipment. That costs me $250. If you buy an Arlo or a Nest or any of that stuff, you know this, right? Like the end user price is lower than that, right? So I had to really make sure that it fit within the constraints of something that consumers could afford. And then the third thing was it needed to be size-wise and power-wise kind of containable. So we couldn't just ship people an i7 with an NVIDIA GTX card in it, right? That wasn't going to work either.
Cool. I mean, one question I really am dying to ask you. So, I thought of you as a very successful entrepreneur. I actually have this memory of watching you pitch the CTO of eBay many years ago, and just thinking like, wow, like your presentation is so much better than my presentation. Just like wondering, like where did you hire this Marcom team that's making this stuff? And so that's kind of how I always thought about you. And so I was really surprised when I was kind of running into some OpenCV bugs, and then I think I found you had like forked.
Did you really find that?
Well,
that's so funny.
I was like, what? Do you like forked OpenCV or something? I mean, I remember just thinking like, is this the same guy that I know? Like, that's not possible. Like, like what is he doing? And so I just was wondering, like, how did you stay technical the whole time, or was there like a moment where you like got back into this stuff, or like what's the story there?
Thank you for the shameful comment. I'm like literally red in the face here. I appreciate the compliment. I love being technical, right? Like, I mean, I have always had this office in my home, which now is where I live, obviously 100% of my time, but I've always kept this, and my wife has always been super supportive of me. And it looks like you have something kind of similar in your garage and all the videos I've seen from you of just, stay tinkering, stay busy, keep my hands dirty a little bit. There was a period of about 3-4 years at my last company, which was an enterprise sales company, where I was traveling so much I couldn't be super technical. But I took about a 1.5 year gap and started getting really, really technical again. And what you found actually, is that there was a version of CUDA, which is the NVIDIA library, that wasn't compatible with OpenCV. I ended up forking it. I ended up fixing the bug so that you could run AI and OpenCV at the same time. Because if you were trying to run AI with OpenCV, you couldn't do it for like a year. And so I forked it. I patched it, and I figured out how to make it so that you could run AI with OpenCV on Linux on the most recent version of CUDA. And I was blown away. Like I did it myself, and I was getting like hundreds and hundreds and hundreds of downloads every single day. I was getting like bugs submitted to me on the main OpenCV branch. And I was like, all right, well, I guess that's kind of cool. It's funny that you ran into it though. And for like a 1.5 years, I was the primary maintainer of like OpenCV for all AI researchers around the US. It was pretty sweet.
That's so awesome. I mean, I remember looking at your patch and just thinking, man, like this is like really deep.
It was like there was a bug in the compiled C code that made it incompatible in terms of the data structure and some of the libraries with the most recent version of CUDA.
And at that point, were you already working on this new company? Was that what was happening, or what?
Well, I wasn't really working on the company. I was working on AI. In fact, I was really fortunate that I got to work with the guys over at Lux Capital. I went to them and just said, hey, I'm going to take a couple years off. I want somebody to bounce ideas off of as I explore deep learning, because I think it's real. And within like a month, I had built I was using genetic learning, but using a deep learning algorithm and some of the new stuff kind of coming out in terms of vision. So I used a vision feature set using some of the ImageNet competition vision libraries, and then running just a stupid genetic algorithm to play Mario World. And I built the world's best Mario World playing system in like 3 weeks. And I was like, whoa, here I am in my little garage, and I can beat the entire game of Super Mario Brothers. This has to be something. I mean, I haven't coded in 4 years, and here I am kind of with the state of the art. And so I went and I worked with the guys over at Lux, and I said, hey, can I spend a year just kind of coming in and out of your office and bounce ideas off of you as to what we can do with this technology? Because I want to make sure that we're thinking about the specific application in a way that can build a business that, for me, what was most important is that it really had an impact on the world, make a dent in the world around us. Because as you said, I know I'm fortunate enough that I can kind of choose the business problem I want to solve. And while making great returns for our investors is absolutely a necessary requirement, I had the ability to take an extra 18 months and make sure that I also did something that, when I look back and I talk to my kids about it, that I'm really proud of and that they are proud of and they can be a part of. And so we ended up spending that time trying to figure out, is there really a business model here? I mean, a lot of people said security is a bad industry. It's one that's dominated by ADT. It's got all these old players, and people buy based on brand and they don't buy based on capability. And I was able to convince them and myself that if you could do a step function in terms of capability, just completely change the game, make something available going from reactive to proactive entirely based on the use of this new AI technology, that we can change the way people buy. And that's the entire thesis of Deep Sentinel, is screw ADT, right? Like, that just doesn't matter. Okay, whoever wants to buy that can buy it. But if I can say, look, you can go from having the police show up less than 5% of the time, 8 hours after your house is burglarized, to preventing crimes 95% of the time, isn't that a different reason to buy? And so that was when I was getting technical again to make sure that I understood what the underlying technology was about. And if I can add one more thing to that answer, my favorite thing I did in that whole period was I started a journal club, because I wasn't technical enough to understand the state of the art at that point. It'd been so long since I'd been in AI, like 12 years, 13 years since I was at Stanford. And so I started a journal club, and just by offering free pizza, all of a sudden I had these 20 people showing up together and just saying, hey, that's a topic I want to talk about too. And we ended up building this little kernel of about 9-10 people that are still going today, 5 years later. Every single week we meet and we read papers together and we debate things. And because they're all smarter than I am, for literally the cost of one pizza every single week, I was able to get them to read this paper with me and then explain it to me. I just pretended that I knew what it was about, and then they corrected all of the underlying nature of it. And so it really kind of reminded me of the power to just bring people together and learn from each other. And again, I think it's been 5 years, and the same group of people, we still meet every single week. We met last night and we read a paper on Facebook's new object detection algorithm.
That sounds so fun. Where did you find these people that are smarter than you?
Dude, I literally just posted on Meetup. I made this thing called East Bay ML. I posted it on Meetup and I started broadcasting. Actually, I did a little bit of Facebook advertising too, like for people that had Python as an interest in their Facebook profile. But I only spent like, $300 or $400, and I got hundreds of people to sign up for this Meetup. And we now are at the point where every other week we do a paper, and then in the alternate weeks we do code, and we literally like load up Colab and code together as a group. And these are now, because we're in COVID, about 20% of the people, we've never even met them. Like, we don't even know who these people are, but they just show up and we broadcast it. And for me, it allows me to stay technical while I'm the CEO of this company without having to kind of distract or like bug my engineers.
That's so cool. What kinds of coding do you do?
Mostly Python and Colab right now at this point, right? So that's, I'd say I do a little tiny bit on chips. So I have like a Coral board and an NVIDIA board and a bunch of like CPU, GPUs in here. And so I do a little bit of that, but most of my work now is really in Colab, just to make sure I kind of stay fresh on where are we at with kind of neural network architectures and how good do they really perform in reality.
To the improvements in ML over the last few years, does it affect your business? Like, is it important to use the very latest stuff to make your company work?
It's not important to make it work. It's important to make it better. And in the words of somebody that I think is, again, way smarter than me, Kai-Fu Lee, said that AI has moved into the age of implementation. It's no longer in the age of science. It's in the age of implementation. I would disagree with it a little bit, right? If you kind of look at the S curve of innovation, right, where you've kind of plateaued out in terms of the actual innovation. I think the neatest thing about AI is that we're at both ends of that curve simultaneously. We have implementations that are at massive scale, right? Like Facebook doing facial recognition on all of your photos. And at the same time, in the last year, we have seen BERT, which from a language processing perspective is a step function better than all the NLP that came before it. We saw AlphaZero come out, which I think is just a phenomenal leap forward in terms of reinforcement learning. And then just in the last 4 months, we saw the new DIRT paper come out of Facebook, which is an object detection algorithm that is also, I think it's like 25% better than the predecessor at mean average precision, right? Like, and then Google had a similar one called efficient det. But to see 20% improvements still in the course of a year, I mean, that's pretty amazing that we're both in implementation and in the research phases. So for us, what that means is that we have to continually be climbing that ladder because we get operational leverage, we get margin, and we get operational effectiveness by continually researching how each of those different new technologies affect our business.
Got it. That makes sense. I mean, has it been an adjustment to go from working on maybe not like safety critical applications to like an application where you really can't afford to make mistakes? Or do I even have that right? Like, I would assume that in your world now, the cost of an error is much higher than with a recommendation system or stuff you've worked on in the past, right?
Yeah, I mean, it is, right? And I think, though, at the same time, I took a card from Elon Musk's deck, which is if you're going to fail early, fail fast, fail hard, and then get to the next plateau, right? Because my advantage in being a startup, again, versus kind of the behemoth of giant slow-moving idiots of the world, not that ADT are idiots, but like, let's just call them idiots for the purpose of this conversation, that you only have really one advantage, and that is your willingness to just look the monster in the eye and fail fast and fail early. So yes, it is a mission critical product, and we absolutely strive to be better than everyone else. But we also recognize that if we're going to make these mistakes and do this learning, we've got to do it in this phase of the business so that when we get to the hundreds of thousands of customers, we're at another plateau.
Mm. And I guess if ADT, if it's true, I wasn't aware of this. If ADT actually, when the alarm goes off, nothing typically happens, then maybe it's okay if occasionally your system has an alarm go off and nothing happens. Is that right? Or
so I mean,
probably not what you put in your marketing content. But
I would not say that it's all right if we don't succeed, but I will say that even in the really, really rare cases where we don't operate as quickly as we would like, we're still 100 times better than the next best alternative. Right. And there's, we have customers where, we've messed up and we have, and that happens. But on average, and in fact, to the 99th percentile, they understand, because they understand that when they went to market and said, hey, like, who are Deep Sentinel's competitors? The Google result list is 0. There's literally nobody else that can do what we do at a consumer affordable price point, and nobody else that does it as effective and at much scale as we do. Mm-hmm. And so they are generally pretty understanding that, like, I get that you're learning. I want you to protect my family. I rely on you. I can't put up with this, but I understand.
Interesting. Yeah, it's funny. I've tried to ask this question to a whole bunch of people, and I think I've kind of stopped, right? But I always wonder, like, with people like working on autonomous vehicles or applications where there's really like safety is like a huge issue, it just seems like incredibly hard to know. Like, I've looked at so many ROC curves in my life and like, picked like kind of where you go in the, precision recall trade-off. But I'm so glad that I'm not in your shoes trying to pick the precision recall trade-off. Like, do you have anything to say on like,
so that for me is a little bit easier. So on autonomous driving, you have to choose left or right, fast or slow, which is it's actually a more hard question than ours, which is show this to a guard and allow the guard to review it. Because I have a trade-off. I can have more guards than I need, and I can show them more video, and I can even show them trash videos for a period of time, because I can afford to do that. As long as I can maintain the fidelity of their operational behavior, I can actually just solve that problem with money. Whereas if you're choosing left or right, like, you got to choose one. You can't choose both, right? And that's, I think, a much harder decision that you really can't solve with money. So they have to go slower. I can go faster and just lose a little bit more money for a short period of time.
Although you can't do that infinitely, right? So that I feel like that logic would like apply anywhere. So at some point you have to like tolerate some amount of error. There's some amount of error you always have to tolerate, right, with these systems. And so How do you even think about that?
There is. So the way that I think about it, again, because our decisions, the core decision, the most dangerous decision that we make is binary.
Mhm.
What you can do is you just perform it as an experiment. You operate at the lower threshold,
Mhm.
right? But then you measure at a higher threshold, and you just
Mhm.
measure the gap here, right?
Got it.
And then you have a level of acceptable gap. And then the second thing that we do is we also measure that across the life cycle of an event. So because we're looking at events that are, let's say, 25 seconds long,
Mhm.
that's 500 frames. And so I actually have 500 opportunities to make the decision to go wild with that event. And
Mhm.
so I don't have to make that decision at this point. Now, I can't tolerate it if it's 20 seconds late, but can I tolerate it if it's 300 milliseconds later?
Mhm.
I generally can. And so what we've done is we've been able to kind of drive this threshold where we keep that number pretty much zero, by the way, to be honest with you. But then we drive other dimensions of flexibility in our decision making instead of driving the decision of I'm going to let this event go, because that we don't consider that to be acceptable, and we keep that number pretty much zero.
Do you pass along your confidence value to the operator?
Great question. No, because in general, what we have seen is that the confidence values, and you see this all the time, right? I'm 99% sure that my cat is a dog, right? Like
Mhm.
it's not real information. I don't find, in the shape of those softmax curves are so sensitive, and the number that comes out is not a true confidence number in the sense that humans interpret them. Like 0.6, which would turn into 60%, really doesn't mean 0.6. In fact, if you look at the shape of most of the softmax curves, they're very heavily weighted on the zero, between 0 and 5%, and between 90 and 100%. There's
Mm.
almost nothing that's kind of in that useful range in the middle. And so
Right.
we tend to just trim it off, because then if you try to normalize it so that it's distributed evenly between 0 and 100, what you're
Mhm.
doing is you're taking basically 0.9 to 0.91 and making that this huge section between 50% and 75% confident. And we find that it's not actually that representative. Like the granularity doesn't really exist in the confidence, at least in the most of the curves that we've seen.
Interesting. Do you ever go back and deploy new models to your customers,
We
like to
do it
existing customers?
all the time. We
And
deploy new models on a weekly, monthly basis.
interesting. And will you train them on the customer's data?
Yeah, so we train them both on the customer's data in aggregate, and then we actually have a patent on personalized training at the edge, or patent pending, that we use the individual customer's data to fine tune the model in their home. And that's one of the
Oh, cool.
neatest things about having the hardware in the home is we
Uh-huh.
have a huge chunk of data in the home, and we also
Uh-huh.
have a model in the home. And so there's a bunch of advancements that have been made in like semi-supervised learning where you can refine these models at the edge. And so we can do that both in terms of how we interpret the final coefficients coming out the fully connected layer, as well as do that on actually retraining some of the weights in the model in the home.
So it'll actually retrain on the edge and not phone home?
Yeah, so we can do some amount of that. We have tended to do that only on the fully connected layer, or like maybe one or two layers, and we've done a bunch of tests to see like where does that matter. In general, we found that even just the fully connected layer, rebalancing the weights of the fully connected layer is pretty effective at driving a massive shift in mean average precision, especially when it comes down to our problem very specifically is we have stationary cameras. And so a big part of stationary cameras in terms of a vision problem is identifying the background. And so when you have hundreds and thousands and millions of images of what a camera looks like on average, you can develop a very clean sense of what the features are of the background so that your background subtraction becomes even more effective kind of across the board.
Do you have any examples of customers that have kind of taken a camera and deployed it in some way that you didn't expect that caused the system to struggle?
I mean, we have tons of examples where the interface with the wet part of the world, the human being part of the world, is wackadoo. We have to have a very specific policy about what you do when you see naked people, for example.
Mm.
So we have customers that we have discovered that, and you know him as well, right? So Sean Parker used to always say the world is broken up into two categories of people: exhibitionists and voyeurs. And I'll tell you, a product that has people watching your cameras, you definitely find people in that first category. And so we have customers that will put their camera in their house and then proceed to treat it as if it were an adult rated YouTube channel. And
I have to ask, and maybe we should take this out, but what do you do? What do you do?
We turn the camera off and we apologize to the guard that had to watch it. So
It's
we
like a
have
good
special
policy.
features where that escalates immediately. We disable it. We send them a very nice letter that says, we noticed that you've installed your camera indoors. We have gone ahead and disabled that. Please verify when you've moved that outdoors and let us know. But I mean, you know, it's a product that touches the real world. This isn't a Nest or an Arlo where it's a dumb device just recording. This is a device that is a live ecosystem. And so we find all kinds of stuff. And this is one of the things I really love about the business that we've started, is that we have this huge, deep technical investment in AI. And then we have all of these different real scenarios that it's being trained against that, you know, when you compare our AI against what you would get from kind of a horizontal vendor that does image recognition and classification, there's no way that they've spent the time to say like, hey, what does it look like when you're inside and there's a guy dancing in his underwear in front of your camera? Like, you know, the Nest doesn't have that, really. They don't,
Right,
they don't
right.
do that, right? Like, and so we've just solved a lot of these really neat technical problems that are at this interface between cameras and human beings that I think is really interesting.
I guess this is outside of AI maybe, but I'm kind of curious as another entrepreneur to entrepreneur. It seems like you have this interesting challenge of like proving to your consumers that your camera is actually better. Like I feel like a lot of things it's like obviously better, but I guess in security it's sort of like better is the absence of issues. Like how do you demonstrate that your camera is better?
It's more of a marketing question, right? In some
Sure.
senses, right? So one of the challenges that we have is that for the last 30 years, the definition of better for cameras is pixels per inch or, you know, color resolution, where, you know, what we did is we changed the game. The camera really is a dumb camera. Like our camera is great and it's as good as anybody else's, but it's not better as a camera. In fact, there are areas where, like, you know, the new version of Nest, the new version of Ring or whatever are technically better than our camera, but none of them do what our camera does. It's more about the capability. And so what we found is that we break that problem down into two challenges. We have to handle the matrix of like, are you better and are you worse? And then the second piece of it's really what you said, which is how do you deliver peace of mind, which is such a dangerous word from a marketing perspective. And so what we've really focused on, we have this series of videos called the stopped videos that show us just stopping crimes, boom, repeatedly over and over. And they're kind of individually boring because, you know, the point where the guy walks up to the front of a 7-Eleven, we have this 7-Eleven that gets burglarized like literally once a week. Guy walks up with a crowbar and he swings at the door, and that's the end of our video because our guards get on and say, hey, jerk, get out of here, the police are on their way, and the guy walks away. Whereas if you had a dumb camera, you get this really cool video that for the next 45 seconds you see this guy banging on a window. And so what we've had to do is we've had to train the market that, like, hey, prevention is possible. Proactive it's much harder to sell proactive in some senses. And so we've really kind of spiced it up and made it exciting and, you know, made these like video series about it. And that leads to the question, hey, how do you guys do that? Right? Like we now have an autonomous AI called AI Deterrent that triggers within 200 milliseconds of the AI detecting somebody suspicious at night. And that's pretty sweet too, because we're literally kind of intervening in these crimes even before it would get to a guard. And that typically buys the guard another 3 to 5 seconds where the person's talking to the computer and then the guard's like, nah, man, I really need you to go.
Do you worry about adversarial attacks, like someone kind of figuring out your algorithm and then like finding ways to go in undetected? Is that, I mean, I would think you might be too small for that to really be an issue, but maybe that is.
I mean, I think yes, we think about it, right? I think about that all the time because, again, my business is security, so that's
right.
That's the way that you have to view the world when you're in security. But from a business perspective, right? Like at the point that we have people really developing adversarial attacks, we're in, you know, at another stage in our development.
Got it. Okay, well, another totally different thread that I wanted to ask you about, because, you know, people ask me about this all the time. I mean, you're a fairly active angel investor and longtime, like, super successful entrepreneur. I was kind of wondering how you think about investing in AI companies, like what you what you look for there?
Yeah, so I have actually made the decision about 4 or 5 years ago to stop angel investing for the most part, because I did okay on some of them, but I found that the people that are really good at angel investing do that full time, and that I didn't want to do it full time. I find it really neat to meet with entrepreneurs and hear their story. And like you, right? Like I like helping, I like kind of being there for them. And the investment piece was in some senses clouding that interaction just because I don't have enough money to invest in every one of the cool entrepreneurs that I see.
Mm-hmm.
And at the same time, I don't have enough time to spend time with a bunch of them. And so what I ended up doing was I ended up joining a venture firm as a venture partner so that they could kind of deal with the investment side of things. And I could just really focus on the like advising and talking to them. And what I've generally seen are kind of two camps of AI companies. And I think this is what you always see with emerging technologies is you see the kind of geeky technology oriented founder who really doesn't understand the business that they're in, and they're just like super smart and they're endearing, like you want to help them. And then you see this schmarmy, like sorry for all the guys out there or gals out there that are this, but like the salesperson, right, that shows up and they're like, and the AI is just amazing. You would not believe it's using this thing called stochastic gradient descent. And you're just like, oh my God. And so after I pull the knife out of my eye, I don't advise those companies, but I entirely focus on those founders that have that chutzpah. They've taken the risk to do something that they are not good at, right? I am going to go and start a business as a tech person, and I've got this crazy great insight. And I find that to be much more compelling and interesting and fun for me versus, trying to educate some sales schmo on what's really happening under the covers.
So I guess you've watched a lot of technical founders become wildly successful. I mean, you've been doing this a long time and have had really front row seats to Silicon Valley. We should, put your bio in the show notes, but it's impressive. Are there any patterns that you've noticed over the years of like, who you meet in that mode as like a technical founder? Because I'm sure that's a lot of the people, watching this, listening to this, and how they actually succeed, like kind of which people are likely to succeed, and then what they do to kind of make themselves successful.
So the two things that I think are pretty consistent is embrace crazy, right? Consistently, right? Like the things that other people aren't doing, that's exactly the world that you have to live in. You can't do all of crazy, right? But if you live in just not crazy, then you're competing with them on their terms. And that is consistently a path to failure. So you have to embrace crazy. And then number two is the technical founders that I have seen get wildly successful. They aren't necessarily really self-aware, but they're sufficiently self-aware to hire their complement. That's either in like one really amazing person or in, two or three or a whole team, but they find some way to remain the crazy person and have a team that embraces that and supports them and gets the other stuff done. So I want to talk about social responsibility because I've seen just this market shift in the role of data in our society over the last 6 months, and not necessarily in a positive way or a negative way, just a kind of a standout observation that if you look at the two or three big things that have happened to the United States and the world in the last 6 months, the COVID, obviously, and Black Lives Matter, both of those have been really hard for our society to get a hold of. Because we have built a society that is headline based, whether you blame it on Twitter or whatever, I don't care. I'm not going to blame anybody, right? It's just that we are a headline based society. And the problems of COVID are so incredibly complex. They are deep statistics. They are statistics that don't lend themselves, and they're so data oriented, they don't lend themselves to a quick, 40-word summary as to what's going on. And so, and same thing with Black Lives Matter, right? Like you could find a Black person that makes more than a white person doing the same job. Absolutely. And if I wanted to, I could, write that article up, ship it off probably to Fox News, and they would run it. I could also find a Black man that makes $100 per hour less than a white person in the same job, ship that off to MSNBC, and they would run with it. And that instantiation based existence-based proofs are exactly the opposite of what statistical distributions are all about, right? A statistical distribution is about capturing the totality of a problem. And COVID, I think, brought the concept of an exponential curve to the masses in a way that, I think 16% of Americans get through calculus and statistics in high school. But now 100% of Americans have been exposed to the concept of flattening the curve and why an exponential curve is important. And then we got exposed to, unintentionally, what happens when you intervene in an exponential curve. Oh, well, but that never was going to happen. Well, now we have intervention-based statistics that now, I'd say less than 16% of Americans are aware of. But statistics have moved from being kind of a fringe thing that affected insurance and financial markets to being something that impacts all of our lives. And I think that's something that is both exciting to me and scary, because we as data scientists have generally lived in this world of like, I'm just living in the numbers. So whatever I say is just the numbers and I have no social responsibility. And I think that's absolutely wrong. That is categorically an incorrect statement. And in fact, I think the opposite is true. It's that numbers have become so important in our society that it's our job to go to primary sources. It's our job to educate our friends. It's our job to read past the headlines and play an active role of helping people understand what a distribution means to those things. And I had a couple of examples for me that really stood out. At the beginning of COVID, there's a great blog called Towards Data Science. I don't know if you read that one, but I like it. I think it's pretty good.
Totally.
And
prolific.
And there was an article written in Towards Data Science that said the cancellation of these conferences is absolutely the wrong thing to do. In fact, I'll just share it for those of you that are watching. It's this article here. He invented this term called coronia, or like paranoia, right? Coronia. And no slight to the author here, because I think we were all learning. So I don't want to slight this author, but I hated the article. And the reason I hated the article was because the paper, the article states, here's the population of Spain. It's 46.66 million people. The total cases of coronavirus in Spain is 2. So therefore, the number of people that would get coronavirus at this conference is 0.0046. And what I really hated about this was that we had an opportunity to kind of have an educational moment and have a conversation. And instead what we did is we chose a false population, right? The population of Spain and the number of cases in Spain is not the problem. We simplified the problem in a way that abstracted out the exponential growth component and the exposure component. And we stopped and didn't believe in intervention, right? We didn't analyze the actual data. And this is the danger of statistics to me, is that you can use statistics to justify something if you just trick people by choosing the wrong population, you trick people by choosing the wrong coefficients, you trick people by using the wrong underlying model, right? And in this case, he used a linear model instead of an exponential exposure model. And that to me, I think, is the quintessence of what we as data scientists must tackle, is to be, sure, we can be opinionated, but to be balanced. And I think it's just so much more important than it ever has been, because we as a population don't have the educational system so that 100% of Americans understand what statistics mean.
That reminds me that there's been, I think, another observation that a lot of folks have made about machine learning algorithms, that, when they're based on training data that could have underlying bias in that data, you can easily end up with models that are like, reinforce society's biases and make it worse. And actually, you make a device that calls the police, right? And so, I mean, how do you think about that in your device and your training data and what you do?
Dude, such an important question. And this is, I just made this big statement that we have to be proactive. We have to recognize that if we just say, I'm agnostic because I live in the data, so therefore I'm not biased, is a falsehood. That is it, and Mark Zuckerberg said that in front of Congress. And I love that he did that, because it shone a bright light on the fact that that is a lie. And I don't know that Mark did that intentionally, because I think we all believed that right up until very recently, right? Like, I don't think we were exposed to our own biases and our own potential for bias until that happened. What's interesting about that moment is I happened to be in Washington, D.C. on that exact same day, and I had called a meeting with the ACLU and the NAACP and a number of other civil rights organizations, and I presented my business to them, and they all said the same thing. And I said, no, we can't be biased because we're based on the data. And what it did is it really forced me to take a step back and say, actually, could I? Let me ask the question. Instead of making the statement that because I'm focused on the data, I can't be biased, let me make the hypothesis. Let me make the null hypothesis that states because I'm based in data, I can't be biased, and then disprove it. And I found that there were just hundreds and hundreds of ways to disprove it. And so we actually designed our system specifically to be race blind. We intentionally designed it to be race blind. We manage the training data coming in so that we can identify people. Then the second thing what we did was we used the data in a way that cannot be abused from a race perspective and an ethnicity perspective. And then the third thing we did, which I did not expect to do. In fact, I came into that meeting with the NAACP saying, we're not going to do this. I said, we're going to not track the race of the people that we call the police on. And they said, in fact, I want you to. I want you to do that, but I want you to store it in a system that's not being used for machine learning. I want you to store it in a system that you use for auditing your employees and you use it for auditing your own business to make sure that you are doing the right things. And so we did those three things, and I feel wildly good about what we did because one, we were proactive. We did it before we got in trouble. We did it before we called the police on the wrong person. Two, it was an educational experience for me, right? Like, again, I was very strongly in the camp. I was in a recommendation system business. I built the recommender at Amazon. Those systems are entirely based on, hey, you just use the data, and whatever the data say, that's what you optimize to. And I was surprised and pleasantly pleased with the results of taking that step back and saying, let's treat that instead of as a conclusion, as a null hypothesis. And I learned a lot.
It's a strong claim, though, that your system can't use race. Like, how do you know that's the case?
So it's not that it can't use race. It's that we make sure that the distribution coming in on the training side is designed to be race agnostic. It's a fair distribution on the input side, which requires tweaking the distribution on the input side. Then the second thing is we don't allow the system to perform specific activities. We don't do facial recognition at this point because we recognize there are some issues with facial recognition. And we don't allow it to call the police. We focus on classifying something that is itself race agnostic. And so we focus on behavior and we focus on classifying people versus cars. We do not focus on classifying suspicious looking person. And we've specifically designed the system to not be able to do that, if that makes sense.
So the system looks for people, not suspicious people.
That's right.
And then if it sees a person,
then it identifies the behavior and it separates the behavior identification from the person identification. This is what I mean by actually designing it to not be able to do that. We do not allow the behavior identification portion, the suspicious identification portion, to know what the person looks like. It does not have access to the pixels. It only has access to a completely removed representation of the behavior. So it's a set of vectors and features that have entirely removed all the pixels.
So it sort of like synthesizes the pixels into some information that then.
That's right. So we created an intermediary data structure, which is, here is this object, here's its classification, and here are the dimensions of its motion. And then we drew a hard line. That system does not talk to the other system that says, based on these motion vectors and this description of behavior, this is suspicious or not suspicious.
Interesting.
Again, it was kind of non-intuitive, right, to do that, because as a data scientist, I would say, I just want to go from here to here, right? That's going to be much more accurate. And from a mean average precision perspective, it might be, but it also is exposed in a real world context to having bias in the end-to-end. But by enforcing this intermediary that gets rid of the pixels that might contain anything having to do with race, it makes sure that it can't propagate through.
And then you collect data that tells you that it's not using race, you're saying? Or like how do
what
you
we do
like
is we
audit
then
that?
collect data in an independent system that says these guards were calling the police on only Latina people or only on Asian people or only on Black people, and making sure that we are auditing all chunks of the system against the racial distribution so that they're acting in a way that is consistent.
And is there any other groups that you worry about? Like, do you look at gender too, or like, other aspects of appearance or anything like that?
We do. So we do track the race, the gender, and then generally the age as well, because age is a really important one. So one of the things that I learned in my meeting with the NAACP is that Black males under 18 are frequently classified both by police and by witnesses as being adults. And you need to treat minors differently, right? Like we have a social responsibility to say, hey man, I see you TPing that house. Like, could you get out of here? All right. And we call the homeowner and say, hey, there's somebody TPing your house. Instead of, hey, asshole, I'm calling the police, right? You need to stop right now. Like that creates, as we're seeing, right? Like the intervention of escalation creates a different outcome. The intervention creates the outcome. And so you better darn well choose that intervention based on real data. And if at the end of the day, Black males are specifically classified by people frequently as being older, then we got to train for that. We got to compensate for that. We got to treat minors as minors because that their brain development is the same regardless of race, right? We have to enable them to develop their brains.
Have you written about this at all? Is there some place we could point people that wanted to learn more about this? I'm just not sure we can cover all the questions that
I
folks
haven't
might have.
written about it as much as I probably should have. I actually just did that. I had that meeting with those groups, and I just did that for the purposes of ourselves. I probably should, at some point write about why I did that and what it means and what the social impact is of that. I did do a little letter to our customer base right when the Black Lives Matter movement was really kind of taking hold. And I said, look, I want you to know what we've done because I'm really proud of it. And I don't want racism to exist in our business because it's so dangerous, right? Because we live at this intersection between human beings and the police. We have a real responsibility to take that at a high level. And I'd say 99% of our customers were like, that's awesome, that you've done that. You don't have to pick a political side to say you've done the socially and business responsible thing. Interestingly enough, we did get 2 or 3 customers that came back and were like, F you, you're making this up.
Wow.
Which was surprising to me.
So the hostility was like, you're making this up, or we don't like that you're doing this?
You're making up that you did this. You're making up that there's a real problem. There is no problem.
Oh, I see.
Ben Shapiro told me that there's no problem.
Right. Got it.
At the end of the day, I very much strongly believe in the First Amendment, and I love that people have their opinions. And again, this is where statistics come to play, right? Like there are no real statistics that say that our country's not racially biased. Like zero.
Well, let me ask you one final question, maybe
Yeah.
a little less intense than that one. In your process of going from like a model to like a deployed system, where have been the surprising bottlenecks? I think everybody like senses that it's hard, but like what were the points where like this took like a lot longer, it was a lot harder than you were imagining that it would be?
Yeah. So number one, first and foremost, is specific operands on specific chipsets. So, for example, Qualcomm implements this huge stack of operands and implements them in a way that you can accelerate. And so as long as you kind of stay in that little pool, you're okay. But all the new architectures typically are using new operands, right? Like that's a big piece of the new papers is they're getting to state of the art by using this new version of ReLU or this new version of a generalization operand between layers. And more activation functions, right? Like all other activation functions that are non-ReLU based. And what we have found is that in the last 3 years in general, that problem is being solved with like a big baseball bat. Instead of being solved like with a surgical tool and being precise, it's being solved with broad swings. So for example, Qualcomm has the problem that if you don't support it, it just crashes. That's sweet. Good to know. Then you've got TF Lite, which I think is a much more robust architecture, and I like TF Lite a lot. But what does TF Lite do? Well, if you're using an operand that isn't supported on your particular architecture, we just move everything from that point forward into your CPU. So you go from a model, you make this tiny tweak to a model, and it runs in 25 milliseconds. And then you make a tiny tweak, and now it takes 750 milliseconds. Right? It's not this kind of like nice smooth curve where things kind of get reconnected in the middle. It's just bah, and it blows up. And as you might guess, right, systems that are based on an assumption of performance between 25 and 50 milliseconds do not perform well when performance goes to 750 milliseconds. So I think we've improved in that, like, TF Lite doesn't crash and totally die. But actually, at the end of the day, your system crashes and totally dies. So you get kind of the same outcome without having a system error, which is, maybe better and moving in the right direction, but certainly not there. It's definitely still a lot harder than I would like. I would say that the second thing that I've learned is how incredibly distinct the world of training is from the world of runtime operations, right? If you're running it in the cloud and you're willing to pay, the GPU prices on the cloud providers, then it's not that big a deal. Any of the more precise architectures, the level of kind of OS tuning that you have to do, the level of, firmware driver management that you have to do, it's a lot more than I thought it was. Again, kind of coming from the Raspberry Pi tinkering type part of the world to actually implementing it and having it run 1,000 times an hour, every single hour, 24 hours a day for 365 days a year in all 50 states. Like, that last mile was much, much more complex than I expected.
Interesting. Cool. Well, thanks so much for your time. I really appreciate it. It's great to talk to you.
It was great to catch up with you. I wish I could see you face to face.
Thanks for listening to another episode of Gradient Descent. Doing these interviews are a lot of fun, and it's especially fun for me when I can actually hear from the people that are listening to these episodes. So if you wouldn't mind leaving a comment and telling me what you think or starting a conversation, that would make me inspired to do more of these episodes. And also, if you wouldn't mind liking and subscribing, I'd appreciate that a lot.